Hi, everybody, and welcome to the last section of real numbers, which is going to be us talking about properties of real numbers. And this is, I have to admit, this is maybe one of the math topics that I particularly don't like the most or the best, just because it's really just talking about rules of math, but they are incredibly important, particularly because we use these rules in practically every single thing we do mathematically when it comes to algebra. So it's almost like a necessary thing for us to be able to do. So the first thing that I like to talk about is the commutative property. And there's the commutative property of addition, commutative property of multiplication. Basically, I like to think of these properties as whether it's you're adding or subtracting two numbers or two expressions, the order in which you do it does not matter. So commutative property would be like commuters. You can move things around. So it doesn't matter for addition. It doesn't matter if you have A plus B or B plus A. The order in which you do them does not matter. It's the same thing as me saying, for example, 2 plus 3. Well, that's 5, which is the same thing as me saying 3 plus 2. If I move these around, the answer does not change, which is 5. Same thing with multiplication. If I do 2 times 3, that's the same thing as me if I were to move them around, do 3 times 2, which is 6. So the answer is the same. What you have to be careful of is that it has to be multiplication. Addition. It has to be multiplication. It cannot be division. It cannot be subtraction. There, the order does matter. Okay, so the next one is called the associative property, again of addition, again of multiplication, meaning to say we're only looking at the operations where I'm adding numbers or I'm multiplying numbers, okay? Associative property, I like to think about associations or the groupings, okay? So the grouping. Okay, and for grouping in particular, we show that with parentheses. So if I were to group a set of numbers together, so if I were to group A and B and I were to add those first and then I were to add C, that would be the same thing as if I were to add B and C first and then add A. So for example, if I were to do 2 plus 3 plus 4 and I were to group the 2 and the 3, that would give me 5. And then if I were to add 4, that would give me 9. If I were to change the grouping and say, okay, I'm still going to do 2 plus 3 plus 4, but this time I'm going to add the 3 and the 4 together. Well, then I'm going to have 2 plus 7, which would also add to 9. So the number here, again, my answer doesn't change. It's just the way in which I got there. Multiplication would work exactly the same. If I were to do, I'll change the numbers here a little bit. If I were to do, say, 2 times 3 times 10. So if I were to group the 2 and the 3 together, 2 times 3 is 6. And then I were to multiply it by 10, that would give me 60. Now, if I were to still do 2 times 3 times 10, but this time I were to multiply the 3 and the 10 together, then I'd have 2 times 30, which would also give me 60. So again, it does not matter the way in which I group these, okay, the way in which I associate these, because it is addition and multiplication. Again, it changes for division or subtraction. Now, the identity property basically says, or there's two of them, I should say. There's the additive identity, and then there's the multiplicative identity. Both of these is if I were to add a number or if I were to multiply by a particular number, I would still get that original number. So if I were to have, say, for example, 8, and I were to add a 0, I'd still end up with 8. Okay, and for the multiplication, if I were to have 8 and I were to multiply it by 1, I'd still end up with 8. So again, that 0 and that 1, if if I were to add a 0 to anything, if I were to multiply anything by 1, I'd still get that original number. And that's why we call it the identity, because it does not change the original number. Inverses. We have talked a little bit about these in the previous real number videos, both in adding and multiplying. There is an additive inverse, which would just be the number itself, just the opposite sign. So if I were to have, for example, 17, its additive inverse would be negative 17, because if I were to add them together, I'd get 0. If I were to have 17 and I wanted to find the reciprocal or the multiplicative inverse, it would be 1 over 17. That would be the inverse of it, because if I were to multiply it together, I'd end up with 1. Basically, it ties back into this identity property. If I were to add the inverse, I'd get the identity. So I'd get the 0 for the adding, I'd get the 1 for multiplication. Okay? All right, we are down to the last few, okay? So properties of 0. Again, we've talked about these before, just we haven't called it the property of 0. We have multiplication by 0. So if I were to multiply anything by 0, I'd end up with 0. And that's what this kind of is showing us here. And then if I were to divide by 0, or if I were to divide 0 by any number. So if I were to divide 0 by any number, which is this one, you'd end up with 0 as your answer. However, if I were to divide a number by 0, then you'd get undefined. And again, we have talked about this in the previous video, but we haven't actually called it property of 0. Okay. Now, the last thing here is the distributive property. And this is something we are going to practice a little bit because it's incredibly, incredibly important. Now, I have in the gray box, basically what we have here is the mathy way of doing it. Basically, all you're doing is whatever number is outside of the parentheses, you can multiply it to both terms of the inside of the parentheses. So for example, here I have 7 on the outside of the parentheses. I'm going to multiply it by both terms inside of the parentheses. So I'd end up with 7x plus 7 times 4, which is 28y. Okay, so same thing for 2. You multiply the outside number, which is 3, by negative 5, and then you multiply it by the 9z. So 3 times negative 5 is negative 15, plus 3 times 9 is 18, and then we have the z. And then here for number 3, now notice I don't have a number, I just have a sign. Whenever we have a sign, we assume, and no number, we assume the number to be 1. So I'm going to multiply negative 1 by 8, by x, and by negative w. So negative 1 times 8 is negative 8. Negative 1 times x is negative x. Negative 1 times negative w is a positive w. Okay, so now I'm going to take the negative 3, for example 4, and I'm going to distribute it, but only to the things inside the parentheses, okay? Keep in mind, this part, that minus 8, is not in the parentheses, so you do not distribute it to that. So that's kind of a tricky thing to remember. So negative 3 times 2x is a negative 6x. Negative 3 times 1 is negative 3. And then minus 8. Okay, now we can simplify that last one. We're not going to. That's as far as we're going to take it for right now. When we go ahead and talk about orders of operations and combining like terms, we'll go ahead and do problems more like that. But so far, I just want us to focus on the distributive property, which we did. We did what we wanted to do. It looks beautiful. And really, that finishes up all of our properties of real numbers. See you next time.